Okay. Hello, hello, hello. Can you hear me? Can you see me? Am I coming in? Can I get a signal check, everybody? Let's see. I'm seeing science games in the house. I'm seeing crypto cruising in the house. I see SFS rocket science all in the house. If you can see me or hear me, just comment something or other and let me know I'm coming through. I see crypto cruising. How fo? Okay, looking good. All right, cool. Thanks. All right, well, we're live. Hey guys, welcome. Welcome everybody to Launchpad Astronomy. I'm your host, Christian Reddy, your friendly neighborhood astronomer. And as my folks on YouTube know me, I'm the friendly neighborhood astronomer or Christian Reddy, but in the classroom, I'm known as Professor Reddy, at least, in front of the students. Behind my back, they probably call me a few other things. What are you going to do? Anyway, what I thought I'd do is have a live stream today because yesterday I was just kind of messing around with YouTube and I downloaded OBS, Open Broadcast Studio, and I didn't know how this thing worked, and I was just kind of fiddling around pressing buttons. Next thing I knew, I was live on YouTube and I had like 7 or 8 people joining in within the first moments. In fact, looks like I've got 8 people now. Hey, Philip W., good to see you. Thanks so much for coming by. And so I kind of did like an impromptu live stream. And tonight I'm giving an exam in my class, and my first exam. And I thought, in case maybe students want to ask me questions, I could use this lunch hour to answer them. We'll see if any of them show up. But then I thought, in case they don't show up, because why? I thought I would just talk about, something kind of boring and non-controversial, such as whether Pluto is a planet. So everybody kind of has, crypto says dump OBS, swap to SL OBS. Oh, thank you, crypto. I probably will take up your advice. I should let you know I'm streaming on a MacBook Air, so this little thing is just kind of going crazy. I don't know if slobs would be better than OBS or not, but yeah, I mean, as I learn how to make a little bit of money on this thing, then sure, I'll try to set up a more professional setup. Anyway, right? This is something that was settled 12 years ago that nobody has bothered to worry about since. Yeah, right. And it's and I see them going in and out. I apologize for that. Let's see. Am I back online? Yes, I seem to be back online. I don't know why I'm dropping off, guys. Oh dear. Why am I dropping off? That's not what I wanted. What is going on here? Why am I dropped off? Okay, I'm getting a warning that I have very stream health. Hang on, everybody. I'm going to try to do something here. Let's see if this is coming through. Okay, I hope that is a little bit better. I seem to be offline again. Good grief, I did not have this problem yesterday, I assure you. Okay. Am I doing any better now? Could be a high internet time, says Crypto Cruising. Yeah, it could be. It's noon here on the East Coast in the US. Maybe people are off lunch, getting off for lunch, and they're going nuts. Sorry about that, guys. Like I said, I'm brand new to this, and I know I'm only coming through every other word. Let me just type that out here. Oh boy, this is embarrassing. uh, 1 terabit per second upload crypto cruising. Good grief, you guys in the UK have civilization. We don't so much. Okay, well, now that I've shut down some apps, come back to the topic at hand, and that is whether or not Pluto is a planet. Now, if you've been following the news since 2006, you know that the International Astronomical Union held a meeting. They held their annual meeting, and on the last day of the meeting, they held a forum, whether or not, what is basically asking what is a planet. And why did they ask this question? Well, Pluto's been a little bit of an outlier ever since it was first discovered. Rather than, a big giant planet out past Neptune that they thought it was initially, it turned out to be this really tiny object. And it not only has a moon, but it actually orbits the common center of mass called the barycenter. It's not like the moon goes around Pluto. It's more like Pluto and the moon kind of go around each other. Well, that's interesting. The second another issue is that Pluto's orbit is, it kind of cuts into Neptune's orbit, right? So if this is the orbit of Neptune, here comes Pluto. It temporarily cuts inside and then goes out again. And if you look at the solar system from the side, okay, this plane that all the planets orbit in, we call this plane the ecliptic. Let's just pretend this is the sun. All of the planets are here in the ecliptic, and there goes Pluto, kind of cocked off at about, I can't remember its inclination, I think it's like about 25 degrees or something like that. Okay, so this got a lot of people wondering, what's the deal with Pluto? Well, it was sort of, this, thing that was out there in the outer solar system, and astronomers kind of were like, yeah, okay, maybe it's a planet, maybe it isn't. So the whole is Pluto a planet debate is really not new. It's actually been going on for decades. But then, in 1992, the first Kuiper Belt object was discovered. It turned out it had an orbit that was very close to Pluto's. Then in 2003, Eris was discovered, and this was round and circular and spherical, just like Pluto. But not only that, but it was actually more massive than Pluto. It's a little smaller than Pluto, but it's actually about 30% more massive than Pluto. So they got to thinking, well, wait a second, are we dealing with a new planet here? Are we dealing with something else? And the whole debate about Pluto's planethood came back. So what happened next is after Eris and a couple of other small objects, a couple other small roundish objects such as Sedna, Quaoar, Makemake, Haumea, and so forth were all discovered, all beyond the orbit of Neptune. Finally, astronomers said, okay, we have to talk about this, we have to settle this out. And so the International Astronomical Union threw that forum together on the last day of their annual meeting in 2006. Hey, Bobby Burgess, how you doing? Good to see you. Thank you so much for coming by today. All right, so that's the story so far. What happens next? Well, they come up with a definition of what a planet is. And again, I apologize if this is something you already know, but I'll just summarize it here. A planet is something that is round. In other words, it's spherical. It goes around the sun. Okay, cool. And then they had this third criteria, which is still really controversial to this day, and it's one that I personally don't like the wording of. And it's called the object has to clear out its orbit. If it meets all three of these criteria, then you are a planet. But if you only meet the first two criteria, such as you're round and you go around the sun, but you haven't cleared out the orbit that you occupy, then you are a dwarf planet. And thus Pluto was reclassified. Now, people say demoted, and I personally hate that term. It's just, in my view, it's a reclassification. but reclassified to dwarf planet. And Ceres in the asteroid belt, which up until this time was the largest asteroid in the asteroid belt, was reclassified to dwarf planet, and Makemake, Haumea, and Eris were also reclassified as dwarf planets. Seems pretty straightforward. Except people kind of freaked, right? They kind of lost their minds over this. Well, not lost their minds, but people to this day are still like, Pluto's a planet, dude. And I'm like, yeah, it is. And the reason why I thought I would talk about this here in this first live stream is because, well, first of all, here at Launchpad Astronomy, we run to the fire. We don't shy away. We're tough over here. I don't know. No, the real reason is that in astronomy, we give bad names to things all the time. We give weird classifications. But this whole idea of what is a planet is perhaps the most controversial. It's the one that people, really get almost emotionally invested in. And Vault Dweller, am I pronouncing your name right, Vault? For me, Pluto will always be a planet in my heart, and I believe I am not alone. No, you are absolutely not alone. As a matter of fact, not only are you not alone with a large percentage of the public, but you're also not alone with a significant number of planetary scientists. People like Alan Stern, who is the project scientist of the New Horizons spacecraft, which flew past Pluto in 2015, feels that Pluto is rightfully a planet, as does Mark Bowie, a Pluto researcher, several others, right? Excuse me. Pardon me. So the reason why this came to my mind, as I said, the first I was joking about running to the fire, but the second reason I decided to talk this up is because there have been a couple articles lately in the news, and I thought about doing this as a video, and I thought, maybe this should be a live stream. This is something that might be kind of cool to just talk with you guys about in real time. And the argument, and this is by the Pluto Planet Por Vida. Hey, Stony Creek Heritage Farm, how are you? Thanks so much for coming by. We're just kicking around Pluto's planethood, just settling it here once and for all, Anyway, these articles were coming out by the colleagues of Stern and Bowie and others, who are basically saying what they've been saying for years, and that is, look, Pluto's a planet. I mean, you just look at it, and it looks like a planet. It's round. It's got an atmosphere. And oh, by the way, thanks to New Horizons, we know that Pluto is the most geologically diverse world in our solar system. It has mountains and valleys. It has glaciers. It has oceans of frozen methane. It even has convection. It has geology. It is the most geologically complex world in our entire solar system, second only to this one right here, planet Earth. Not only that, but it has a moon. Although, again, I argue it doesn't really have a moon. It kind of has like a co-planet in Charon, but that's another thing I could talk about later. And now the question is, what's the difference? Well, the arguments that they make is that not only does it look like a planet, not only does it behave like a planet geologically, but all of its geophysical properties scream planet. And oh yeah, it does orbit the sun, but so what? Anything that's small and round should be thought of as a planet. And why is this? Because at the geophysical level, the fact that something is round is important. Because when something is round, that means it has enough mass, therefore it can exert enough gravitational self-gravity to pull itself into a round shape. And that's important. That represents kind of like a critical mass in terms of, how much of something there is. When a body can achieve a spherical shape, and in the business we call this hydrostatic equilibrium. When something achieves hydrostatic equilibrium, that is, it pulls itself into a sphere, now we're dealing with something that can have geology, right? It can have geophysical processes. It can have things like convection, and it can have probably an internal heat source. I mean, things can happen. Doesn't mean that things will happen, but it means that things can happen. And that's significant. Really quick, just want to shout out a few folks who dropped in. Dr. Sten Eckberg, oh, hello, sir. How are you, doctor? Peter Quinn, hi, Peter. How you doing? And Miriam Harvard, fellow Be More YouTube person. So good to have you all. I'm so thankful you could join me today. We're just talking about Pluto. No big deal. So anyway, Pluto is a sphere, and at the geophysical level, it absolutely screams planet. Okay, there's absolutely no question about it. However, and there's always a however, because I hate the expression "that being said." Okay, but however, and Peter Quinn, yes. How about binary planet? I actually really firmly agree with that diagnosis, and I'll talk about that in a little bit. Remind me, Peter, if I don't mention it's binary parenthood. Hey, Anthony, how you doing? Good to have you here, my first live stream. So yeah, put a pin in that one, Peter, for me, and make sure I address it. Okay, so what goes back to, getting back to Pluto for a second. Okay, where was I? Talking about the geophysical things. Here's the thing, though. Planetary scientists who study Pluto, okay, and I'm not saying all planetary scientists. And by the way, I need to qualify this. I'm not a planetary scientist. Okay, my background's in binary stars. I'm just some guy with an opinion on this, or a thinking, and it's a thinking that's evolved over time. I want to be really clear about that. I used to think, yeah, Pluto's a planet. Pluto should be grandfathered into the Planet Club. Pluto's a dwarf planet. Pluto is considered a planet by people who study round objects in the solar system. And that makes sense because when you're considering just the geophysical characteristics of something, we can make comparisons all the time. You want to make kind of apples to apples comparisons. For example, Titan has an atmosphere, but Mercury doesn't. Why is that? That's interesting. Okay, the moon doesn't have an atmosphere, but Europa has frozen lakes. Okay, you notice I'm mixing moons and planets here, and that's A-okay when it comes to the context of trying to compare apples to apples in the solar system. Now, you can easily compare, you could easily compare, say, Miranda at Uranus to, a rocky, lumpy asteroid, but it's kind of hard to make that comparison because there's so many things that are different about it. So, from a geophysical standpoint, it does make sense to just regard them as, use the term planet if that's the jargon you want to use. And that's exactly the argument that's being made today. Let's just keep calling it a planet, and the hell with it. Let's just call them all planets. Our solar system would have 177 planets and counting. Well, the other side of this argument is that, not for nothing, but dynamics matter. I mean, if you're kind of studying the solar system from afar, or now that we're examining other planetary systems around distant stars, it's pretty significant which objects are planets. I mean, and the reason for this is because they dynamically dominate. What they do is that they basically overwhelm any objects in their orbit and does one or two things. It either draws them onto the planet, crashing into it, or it scatters it out of its orbit, or the objects just kind of collect in a kind of gravitational balance zone. So I guess one of three things, right? They kind of collect in a gravitational balance zone called the Lagrangian points. Okay. I'll say this as far as this definition of clearing out the orbit. By that definition, nothing ever fully clears out any orbit. Think about that, right? I mean, Pluto cuts into Neptune's orbit. Is Neptune not a planet? Of course it is. But the thing is that Neptune and all these, Neptune, Uranus, Saturn, Jupiter, Mercury, Mars, Earth, Venus, and Mercury dominate their orbits. Dynamically dominate their orbits. That means that they are overwhelmingly, the most massive things in their orbits, but more important than that is that they dominate their orbits, okay? They clearly have a characteristic about them that distinguishes them from all the asteroids, all the comets, and all of what we now call the dwarf planets, so the Kuiper Belt objects and so on. Okay, so let me just quickly take a look at a couple of comments that have come in here, because I don't want to be ignoring anybody. Miriam Harvard, thumb, cool. Peter Quinn, Pluto is cool. Yeah, it's really cool. It's I think it's something like minus 300 degrees Fahrenheit cool. It's pretty cool. Yeah, and Peter is mentioning Sedna, Charon, and Makemake. Absolutely right. And has the astronomer community, Anthony's asking, has the astronomical community settled one way or another on whether Pluto is a planet? And no, actually, there's still some controversy, and that's because there's been some articles that have been published by planetary scientists saying that no, Pluto's still a planet, yo. Okay. Okay, Crypto asked, I have a question for you when you're finished. Why is GJ504b, aka the pink planet? If you know anything about it, why is it pink, and is there any explanation for it? No, I don't know why it's considered the pink planet. I assume that has something to do with its spectral signature, and it's showing up in kind of like a light red part of the spectrum. It's peaking, but I honestly don't know much about it. I'll have to check that out. Maybe that'll be a fun video to make. Thanks, Crypto. Is there any active programs that are searching for Planet 9, Vault asks. Yes, there are several active programs, and we're actually now in Planet 9 search season. That means that Earth is at that part of its orbit where the Sun is this way, and Planet 9 should be somewhere that way. So from now until I think the springtime, there's an active campaign searching for this so-called Planet 9. Let's see. Yeah, about mods. Yeah, I'll have to figure out how I want to handle mods and stuff like that. I remember in school being taught it was a planet. You know what they teaching the kids now? No, I don't know what they're teaching the kids. Hopefully they're teaching them a little bit about this controversy, because I think it's actually good for the public to know that there are these questions that we still don't know the answers to, that science is not something where we know everything, because let's face it, if we did, science would stop. We need to know. We have to ask these questions, and some of these questions are still not answered, and that's okay. That's exactly what we need scientists for. That's what we need those kids to grow up to become. But yeah, you're right, Peter. Mike Brown is the main leader of the search for Planet 9. Okay, so back to Pluto and back to dynamics. If we have objects that are gravitationally dominating their orbits, Pluto doesn't do that, right? And so a question comes, it says, well, if Earth were put into Pluto's orbit, what then? Well, okay, so if you're in Pluto's orbit, you're now entering the Kuiper Belt, right? You have all these scattered objects, maybe hundreds of thousands of these scattered objects. And it turns out the answer is that Earth, if it were moved into Pluto's orbit after the dynamical models have been crunched and the numbers have settled out, turns out that, yeah, Earth would actually influence all the objects in its orbit, even if it were out at Pluto. That means that Pluto and everything else would get scattered into more distant orbits. Now, if you sent Earth deeper into the Kuiper Belt, well, then the objects are even more scattered, and they're just that much more. They're going to be that much more difficult for Earth to scatter. So does Earth then become a dwarf planet? The answer, I think, is yes, it does. And I think that's important because when you have this idea of a dwarf planet, okay, I know this is something that's not very popular among the Pluto Por Vida crowd, okay, but my thinking about dwarf planets, to me, that's important. It's important that we come up with ways of subclassifying and organizing things, because nature never puts these things into convenient bins for us. The reason why we bother putting things into bins or classifying planets versus asteroids versus moons versus whatever is it helps us to ask these. It leads us to these questions, right? It leads us to these. It doesn't mean that we can't ask certain questions if Pluto is a planet and only ask other questions if Pluto is a planet. I mean, that's not what we're trying to say here, but they help us to think a little bit more deeply. Like, well, okay, what would it take to stir up the Kuiper Belt? What is the minimum mass that you need? What does Pluto have to do? How much weight does Pluto have to gain in order to become a full-fledged planet? I think these are interesting questions. I think the fact that you can have a object like, say, Mercury be a planet close to the sun and cease to be a proper planet. It would just be a dwarf planet if it were out in Pluto's orbit. Well, then I think that tells us something about the way solar systems evolve, right? Because once upon a time, there were 100 some odd planets just here in the inner solar system. There's all kinds of things that happen to planetary systems over time. And that to me is what's exciting about science and lets us ask these questions. Okay, so let me see some of the questions that have come in here. Vol is asking, okay, do I think that Planet 9 is flat, just like Earth, and that being the reason why it's almost impossible to detect? I see what you did there, Vol. Anyway. Yeah, I don't think so. Peter Quinn, if we knew everything, scientists would be out of a job. Yeah, there is a little bit of job security there. Philip W., question, do you feel New Horizons helped reignite the public and scientific community to support the idea that Pluto is in fact a planet? I personally feel that it did. You know, I know that it really did get a lot of people going, yeah, Pluto. In fact, I've seen Alan Stern and others in photos. They're doing this, as in like my solar system has 9 planets, even though they would argue that actually my solar system has 177 planets once you throw in all the moons. But yes, I certainly believe it has reignited public interest in Pluto. It's reawakened that discussion, and I don't think it's going to get settled anytime soon. I personally just believe it's contextual. If you're into geophysical models, you could care less about whether it can scatter everything out of its orbit. All you care about is what the object is doing, right? And so I can totally understand why Stern and others would call Pluto a planet. I totally support that. But I'm also supportive of the idea that, there's something that is fundamentally different about an object that can influence all of the other objects near it, and something that cannot. That to me tells me something about the dynamics and the history of the solar system and how it formed. Let's see. Hey, MU, free music for your videos. Hey, good to see you, man. Thank you so much for coming by. Crypto asks, what's the professional astronomers' feeling about Seti? Do you guys get along, and are you looking for different things out there? Yes. We are certainly thinking about, well, let me put it this way. There are teams of astronomers who are dedicated to Seti. As far as I'm just trying to make sure I understand your question about looking for different things out there. Yeah, I mean, people are looking for different things. I guess, Crypto, are you asking, are they looking for different signatures or different signals from ET? I guess I don't fully understand your question. Okay, let's see. Peter Quinn, NASA did fake the moon landings, but Stanley Kubrick wanted to film on location. Yeah, sure. Okay. I'm the Linnaeus of planets and structure. Oh, boy. Oh, golly. So, yeah. Do planetary dynamics matter? What do you think? What distinguishes a planet from a non-planet for you? If it goes around another planet, like if it's actually orbiting the other planet, is it still a planet, or does it become a moon? What about dwarf planets? Or I'm sorry, not about dwarf planets. What about planets that are free floating, right? That are out there, that are not attached to any star, that are just wandering through space. See what I did there? Wandering. What about those? Are they planets? Is the ultimate goal to find life out there? Crypto Cruising asks. The ultimate goal. Okay, I see what you're asking. No, there is no ultimate goal. I would say that detecting. I mean, I think that if we were to detect life, incontrovertible proof of life out there, and I'll even go one better, incontrovertible proof of intelligent life out there, astronomy would not stop. We would always be asking more questions, and that's the great thing about every scientific discovery. Every discovery or every finding leads it ignites new questions. So whether you're looking for life, or whether you're trying to understand how stars evolve over time, or whether or not you're trying to understand how galaxies form, or how planets, evolve and planetary systems evolve, those types of questions will still linger. There'll always be some aspect of those questions. So that's why I don't consider the search for life to be the ultimate goal. But I certainly believe it would be the most profound finding to absolutely know for certain that we are not alone. I personally think that the odds of intelligent life in the universe is exceedingly rare. I would not be surprised if we found that, oh boy, we're getting a raid from Needs More Subs. Hey Joy, how you doing? Needy raid. Oh my gosh, you guys are great. I simply Shannon. So anyway, I personally believe that there's that the searching for life, is just a starting point. But I think that the idea of finding intelligent life, we could very well be the only intelligent, quote, intelligent life in the entire Milky Way galaxy. 400 billion suns, and we're the only one, right? That's a possibility. That wouldn't surprise me. In fact, I think that there could be several galaxies that don't have any intelligent life. Now, I'm thinking, though, that Peter says, I'm thinking life is abundant, but intelligent life, now there's a question. Yes, I agree with you, Peter. Hey, Chandra. Hey, Pusa. How you doing? Oh, I'm so flattered to be rated by this wonderful community of Needs More Subs. Needs More Subs is doing a live stream now, and I totally forgot, and I scheduled this at noon so that my students could come in and ask me questions ahead of tonight's test. Oh, I'm sorry, I don't call it a test. I call it a celebration of knowledge. Anyway, Modern Family Man, Patty Broussard. Oh, gosh. Anyway, how you doing, Patty? Thank you so much for coming. So yeah, I'm giving my first celebration of knowledge tonight, and I thought, well, if my students have questions, they want to catch me on their lunch hour, this would be a way to do it. Are there any science games, and is there any planned mission to Pluto? I think there definitely ought to be a return mission to Pluto, and this time to get into orbit. Couple of issues with that. I mean, the short answer is no. There are no planned return missions to Pluto at this time. But given what we've glimpsed or tasted of Pluto, we found this to be the most geologically diverse world in our solar system, except for Earth itself. So if there's a way, take care, Patty. Bye bye. To give Needy my salute and my regards. Tell the captain his loyal subject is out here fighting for him. Yeah, I teach English and I call homework home fun. Yeah! Fun for somebody. All right. Anyway, so I'll just say this. Getting to Pluto and staying in orbit right now with our current technology, we would have to launch and then start slowing down about halfway through, right? We have to carry the fuel on board, try to figure some way to do that. That would basically result in a very long journey. Okay, it took 9 years just to launch at the fastest speed possible and make it to Pluto and fly past Pluto in just 9 years. A mission to Pluto to get into orbit with our current technology, with the best we could manage, I think some studies have been somewhere in the order of like 20 years. I could be wrong. It would take a very long time. And people tend to, want to be alive so that they can see their project come to fruition. So who knows? If that could ever get funded, I would be completely in support of it. That's a long answer to your question. Sorry about that. Let's see. We got Heather over 100 subs. Hooray, Heather! Fantastic! Get to the farm. Hey, good to see you. Get to the farm. We're just talking about Pluto and planethood and other things. If you have any other questions that have nothing to do with Pluto, please feel free to ask. I'm not going to be one of those, hosts that say, no, we're only going to talk about... No, it's whatever you like to chat about. Science Games mentions we can still use the gravity assistance of Jupiter and more. Absolutely. That's how Pluto was further accelerated. It made a flyby of Jupiter. The challenge there is that once you fly past Jupiter, you accelerate. Well, actually, if you fly past Jupiter the other way, you'll decelerate. You'll slow down. But you go even faster. Well, now if you're going even faster, now you have to have more fuel on board to really put on the brakes, and then you got to launch that fuel. Yeah, that's going to be tricky. Philip W. says, I found that planets revolve around the sun, have a heliostatic equilibrium, and would need significant external influence in order to upset its orbit outside the sun's influence. That would exclude smaller Kuiper Belt objects, but allow for objects such as Eris, Makemake, Ceres, and Pluto. Interesting idea. Is that your thinking, Philip, or is that something that you said I have found, and I was wondering, did you find that online somewhere, or did you find that, or are you just finding that from your own thoughts on the subject? Let's see. Get to the farm. Over 700 now. That name change really helped out. Oh yes, I have over 700 subscribers. Says thank you. It's really been it's been great. Let's see. And Science Game says 85. You keep getting after it, Science Games. Keep getting after it. Cam Albert. When satellites are being launched, how do rocket scientists predict how to slingshot the rockets just right? Well, the good news is that we understand the motion of the planets around the sun very well, and we can predict where Jupiter will be very precisely at any given time. And then from there, we just kind of work our way backward. Okay, so we could say, all right, well, how fast would we need to accelerate in order to reach Jupiter by a certain date to conduct a flyby? And by the way, can we approach Jupiter at the right angle such that we'll continue past Jupiter onto our desired target, such as Pluto or now deeper into the Kuiper Belt? So it's a lot of figuring out, where you want to be and when you want to be there, and then figuring out what direction you need to launch in and precisely at what time you need to launch during the day or night to get your rocket moving in the right direction to be where Jupiter will be on the right date and time so that you can fly past it and then arrive at your target on the right date and time. Easy, right? But yeah, as Get to the Farm says, it's a lot of math. But it's actually well understood math. That's the good news about this. This is very well understood. Isaac Newton gave us the tools to do these types of calculations, a couple hundred years ago now. So yeah, we're good to go on that. Philip, that's your opinion of what a planet is. I'm of a mind that we need more planets in the solar system and not less. That way we aren't one of the freak solar systems. Well, yeah, we are starting to... Our solar system is already a freak solar system. I mean, when you look at all the exoplanetary systems that Kepler detected, you find systems that their planets are really close. I just did a video about this, about the 2 new planets that TESS discovered. And what did they come up with? Well, they found 2 planets. One is so close that its orbital period is 6 days. Its year is 6 days. The other one is even closer, and its orbital period is 11 hours. Okay, these types of ultra short period planets are not uncommon. I'm not saying they're the most common thing, and they're not uncommon. Then you got things like the TRAPPIST system, where you have all these planets close together, and then you have other systems. Now, part of it's a selection effect. Okay, part of it is the fact that because they're short period, they're that much easier for us to detect. So we have to factor that into our assessment. Nevertheless, what we find is that our solar system is unusually spread out, a little bit more so than most of the others that we've detected. In fact, more than just about all of them. And so the question then comes, is that, are we abnormal? Or is it a selection effect and those other solar systems will eventually, expand outward, right? Their planets will separate farther from their stars. And that we don't really know yet. We don't really know the answer to that. But to me, it's got to be telling us something about the evolution of our solar system. Again, dynamics matter. And the types of objects that you need to have in your planetary system in order to influence them over time, and by over time, I mean over billions of years, okay? To me, that's very significant. So why is our outer solar system so scattered outward, and why did the Kuiper Belt get there? Well, the answer is that Pluto and Uranus, actually, it used to be Jupiter, Saturn, Neptune, and Uranus, right? And then there was, over time, a kind of a dance You know, as the planets did their thing going around the sun, they would just gently gravitationally perturb one another until finally, they kind of scrambled. And Neptune and Uranus exchanged places. Saturn, Uranus, and Neptune got much farther away from Jupiter's orbit and the sun than they currently are than they used to be. And Neptune just scattered everything out. It just stirred up the pot of the outer solar system, taking all the rocks and icy objects in its orbit and sending it off into what we now call the Kuiper Belt. So it's important to think about dynamics, and that's why, when you are doing these dynamical models, when you try to model Pluto's influence on all this, for example, it doesn't really do anything. If you try to model Eris, which is more massive than Pluto, it doesn't really affect anything. If you try to model all of these dwarf planets, they collectively don't do much of anything. And this comes all the way back to, do dynamics matter or do they not? I think that they do, and that's why I personally like the definition of a dwarf planet. To me, at least, and again, just my opinion here, but to me, that just opens up a whole new category of objects that we can investigate and compare to each other and understand what else is different about a dwarf planet versus a classical planet, I guess. Understanding those differences at a deeper level, I think, is an interesting question. Again, it raises those questions. Now, whether or not you agree with that, I totally understand if you don't. I know that there are people who actually study Pluto for a living that wouldn't agree with me. And again, this is just my opinion. But I think that to me is the salient point here. Understanding at what level do dynamics play versus geophysical properties only. So anyway, so Get to the Farm says, figuring the trajectories in a stayed flat orbit is crazy enough. Then you have to figure the actual movement through the universe, and it gets really crazy looking. Okay, I'm glad you brought that up, Get to the Farm. I know that there was a video that went viral a few years ago where it showed, here's the sun and here are the planets going around it. But the video then points out, but the sun is moving through the galaxy, and so the planets are doing this, and you get this helical vortex surrounding it, right? Yeah, it's true. The sun is flying around the galaxy. It orbits the mass in the middle of the galaxy like all the other stars do. However, it doesn't actually affect the trajectory of anything. We don't actually have to take this galactic motion, this so-called vortex motion. It's not really a thing. We don't have to deal with it. One thing that is certainly misleading about that original video is that people interpreted it as the planets are lagging behind. Like, there goes the sun, and the planets are lagging behind it. If you look carefully at that video, actually, to the artist's credit, he didn't actually do that. So I think he was cool there. But if you look at the original video, he talks about, it's a vortex and life is a vortex, all that kind of stuff. And no, it's not true at all. But no, we don't have to worry about. We can treat the trajectories. We could treat the solar system as flat, right? At least as far as the orbits of the planets, and everything else is, at some angle inclined to the plane of the planets, or what we call the ecliptic. Stony Creek says, I fundamentally understand Kuiper and its spatial relation. Can you talk just a second about the Oort cloud and its effects on the solar system? Okay, sure. So we've talked about the Kuiper belt. And if the Kuiper belt, just to put it all into perspective, again, if my students are watching, you know what this is, but if you're a little rusty, an astronomical unit is kind of like our yardstick in the solar system. It's the distance from the Earth to the sun, about 150 million kilometers. So this is not to scale. Earth is 1 astronomical unit from the sun. Mars is 1.88 astronomical units. Jupiter is 5.2 astronomical units, and so on. Well, when you get out to Neptune, you're at about 30 astronomical units, and the Kuiper belt extends out to about 55 astronomical units. The Oort cloud, on the other hand, depending upon what model of the Oort cloud you'd like to go by, starts at about 50,000 to maybe 200,000 astronomical units. So we're getting very, very far from the sun. So they really don't play, they don't have any dynamical impact to the inner solar system, right? The solar system that you and I are familiar with one exception. And that is occasionally there's a chunk of ice from the outer Oort cloud that'll get perturbed from its present orbit around the sun, and it will begin to gradually fall toward the sun. And they'll come in not, just along the plane of the solar system, but they'll come in from crazy angles. And they can come virtually from any random direction. They'll make these very close approaches to the sun, and sometimes they'll survive. Other times they'll just burn up in the sun. We call those types of comets sun grazer comets. So they don't impact or they don't affect the solar system, the inner solar system, too much, unless there's a freak impact somewhere and it lands on a planet, makes for a good show. But it doesn't really affect our inner solar system. Let's see. It's only 5 galactic years old, our Sol. Yeah, right. Our sun, let's see, 225 million year orbits. The galaxy's on the order of about 12 billion years old. So yeah, do the math. And you could see how many orbits our sun has probably made around the galaxy by this point. It's sad they can assume our solar system is average and all others should look like ours, lol. Well, I mean, if anything, when we don't know any better, right, we say, okay, let's assume we're average and let's see what's out there. Well, what do you know? Everything's weird. Well, clearly not everything's weird. We're the weird ones, right? So our thinking evolves, and that's science. In terms of object composition, is there a fundamental difference between the objects in the Kuiper Belt and the objects in the Oort cloud, or do we know? The short answer is we don't know for sure, because the only Oort cloud objects that we've ever seen are comets. Could there be anything more massive out there and more Kuiper Belt-like out there? Yeah, there certainly could be. We just don't know. We haven't seen anything that's provably from the Oort cloud other than the occasional sun grazer comet. One thing that we can tell about those Oort cloud comets is that they're mostly ice, and they're very, very similar to Kuiper Belt objects, at least as far as I understand. If there's any Kuiper experts out here, please let me know, because I'm only telling you what I know, and I could be wrong, so a little caveat there. But I believe that there really isn't a whole lot of difference. Once you get out into the Kuiper Belt and beyond, then you're just dealing with mostly rocky, icy snowballs, and the farther out you get, the more ice and less rock you get. Hey, Crypto, take care. Thanks so much for dropping by. Get the farm. Then they found binaries are the norm, and we are a bit different. Hee hee. Oh, you mean binary stars? Yeah, binaries are about 1/3 to 1/2 of all of the stars in the sky belong to binary systems. Our sun doesn't. And that, again, raises another question. Did that somehow influence the evolution of our solar system? Is it possible that our sun had a companion at one point that, accelerated away? Probably not. But is that possible? So these are the kinds of questions that get raised when you're making these comparisons. Oh, gosh. How are y'all doing here? Let me just get some water here. Any other questions? So back to my question for you about the definition of a planet. What do you call the things that are out there wandering around among the stars that don't have stars to orbit? They're not stars. They're not brown dwarfs. Should we call them planets? I personally think we should. I think that's a reasonable definition of a planet. Small things that are round and aren't stars. However, and there's always the however, right? What happens if you take that object and you put it into a planetary system? Does it then remain planet, or is it now a dwarf planet? I don't know. I kind of think that it depends on its mass, right? It depends on Can it dynamically influence the things around it? Can it scatter everything in its orbit, or does it share its orbit more or less with other objects? Well, again, to my mind, if it scatters, then it's a planet. If it doesn't, it's a dwarf planet, and that's cool. What happens if Earth falls into orbit around another planet? Is it a moon? Yeah, we become a moon. Any news of Hayabusa 2? Science Games asks. I saw the news. It looks like they've got their 2 rovers landed on the surface. And these 2 rovers have the cutest names. They call them Rover A1 and Rover A2. Yeah, JAXA really needs to come up with some better names. But anyway, they successfully landed I think it's their first 2 rovers. And these rovers, they're not, Science Games, you probably know this, but these rovers are not the Mars rovers. The first instinct was to give them little wheels to roll around on. The problem, though, is that Hayabusa 2's surface gravity is so low that the wheels would never be able to gain any traction. The rovers just wouldn't be able to put any weight onto the asteroid. So they've landed on the asteroid, and we're calling them rovers, but I think hoppers is a better term. They actually have little spring-loaded legs, and then they pop up, and then they come back down at a new location. So they're not rovers, they're hoppers, but they have successfully landed, and I believe that they're going to be landing some more in the weeks ahead. And then there's going to be a sample return. This is a pretty ambitious mission that JAXA is undertaking with Hayabusa 2. So looking forward to some cool results. What else we got going on here? So as far as settling the question of planets and Pluto and things like that, I know we didn't really get to do that in this conversation, but I feel that, again, I'm just sharing with you my thoughts on the matter. I thought about doing this as a video. I thought maybe this would just be better off as a live stream, because when I do my videos, I'm trying to share with you what we know, and here I guess I'm sharing with you maybe what we don't know. I don't know. But I think the whole idea of having Pluto as a dwarf planet, for me, is okay. I'm cool with it. Again, as I said before, that just opens up a new category of objects for us to study and to ask further questions of. Philip, if a rogue planet were to wander in and assume an orbit, given the influence of the sun, does that make it a planet? Pluto always seems to be an odd one out among the ice and gas giants to me. Yeah, well, yeah, that's exactly the whole thing. And Pluto's always been an oddball. By the way, why did they find Pluto? I mean, let me just raise that question and discuss that with you. They were looking. Okay, there was a guy named Percival Lowell. Lowell was a very famous astronomer. He was also a very wealthy guy. He built his own observatory. He's the person that popularized the idea that Mars had canals and thought that Mars had a civilization drawing the last bit of water from the polar ice caps of Mars. Okay, yeah, and he made some mathematical. He did some calculations on Uranus and Neptune's orbits, and he concluded that those 2 planets, their orbits were being perturbed. That there must be yet another massive planet, like a giant planet, out beyond the orbit of Neptune. And so he worked out where he thought this planet should be, and he looked for it. He couldn't find it, but the guy that he hired, this farm boy named Clyde Tombaugh, found it in 1930, long after Lowell's death. But he didn't find a gas giant. He just found an object that just happened to be there. And so, yeah, it was initially thought to be, even more massive than Jupiter. This was going to be the big, huge mega planet. And suddenly it was realized that no, for it to appear that faint in the sky, at the distance it was computed to be at, it has to be really small, really tiny, and not very massive at all. Well, they looked at the orbit some more, and they quickly realized, hey, you know what? Not only is this thing small and tiny, because, to me, size doesn't matter. It's whether or not it can influence anything. But not only is this thing small and tiny, but it's also cutting into Neptune's orbit, and it's also inclined to the plane of the solar system. So it really received oddball status, maybe not from day one, but certainly within a couple of decades after its discovery, it was really confirmed to be a strange duck. And like I said, that led to questions even going back as far as the 1940s, I believe, as to whether or not, or certainly by the 1960s, I'll say that much, is Pluto a planet? And people were wondering, it probably isn't. It's probably, just a rock or something like that. Well, they verified that Pluto was in fact round, okay, and it's spherical. So it has enough gravity to pull itself into a spherical shape. But now we've got all of these other objects that are out there that just don't seem to be able to influence the rest of the solar system. Neptune, on the other hand, influences them. They are in the orbits they are in because of Neptune. And interestingly enough, Pluto is in what's called a resonance with Neptune. That means for every two orbits of Neptune around the sun, Pluto completes one. And the orbits are arranged such that Neptune and Pluto are never close to each other, right? So instead of this, they're always going to be far apart if the sun's in the middle. And so they're always going to be, Neptune's acting as a kind of it's locked into this resonance, and Neptune can never scatter it away. Well, that must be special, right? Pluto must be there for a reason. It must be in that orbit for a reason. And I think the answer is yeah, it's probably in that orbit because everything else